Need a simple way to expose Python functions as tools that AI models can call directly? You'll see how to create a basic FastMCP server with a single tool function, then run it with just one line of code. The pattern handles all the connection logic for you, so you can focus on defining what your tool actually does. From FastMCP, import FastMCP. MCP equals FastMCP, my server. At MCP, tool. Def hello name, SDR. Return hello name. If name equals main. MCP, run. Hash uses STDIO transport by default. This demonstrates the decorator-based RPC pattern, where Python functions become remotely callable tools through simple annotations. The @MCP tool decorator transforms ordinary functions into network-accessible endpoints, while the FastMCP instance acts as both a registry and transport manager. What makes this distinctive is how it preserves Python's native type system while abstracting away the underlying communication protocol. The pattern works by separating interface definition from implementation through declarative decorators. Your business logic remains clean Python code, while the framework handles serialization, transport, and protocol specifics. This creates a clear boundary between what your code does and how it's exposed, enabling the same function to work across different transports: STDIO for local tools, HTTP for network services, without modification. This approach solves the problem of RPC boilerplate while maintaining flexibility. You avoid writing custom API layers, yet retain full control over tool behavior through Python's native features. It's particularly valuable for AI integrations, microservices, or any scenario where you need to expose backend logic to diverse clients without coupling your code to specific transport mechanisms. The trade-off is framework dependency, but the productivity gain for RPC-heavy applications typically outweighs this cost. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools. It handles the heavy lifting of exposing Python functions to AI models, managing serialization, validation, and transport. Without this, your functions wouldn't be discoverable or executable by AI systems. MCP equals FastMCP, my server. Instantiates the FastMCP server with the identifier myServer. This creates the central coordinator that will register, validate, and route all AI-callable tools in your application. The server name appears in logs and tool discovery interfaces. At MCP, tool. Def hello name, SDR. The @MCP tool decorator registers this function as an AI-callable tool. FastMCP uses the type hints and function signature to auto-generate the tool schema, ensuring the AI knows exactly what arguments to provide and what return type to expect. This is the core pattern for exposing Python functions to AI models through FastMCP. Return hello name. This implements the tool's core logic, returning the formatted greeting string. The F-string dynamically inserts the name parameter into the response, fulfilling the tool's contract defined by the type hints. This is the actual business logic that AI models will execute when calling the tool. If name equals main. This is Python's standard entry point guard. It ensures MCP, run, only executes when the script runs directly, not when imported as a module. Prevents accidental server startup during imports. MCP, run, hash uses STDIO transport by default. This launches the FastMCP server using standard input-output as the default transport layer. It blocks execution to handle incoming AI tool calls, routing them to your decorated functions like hello. FastMCP tool decorator pattern. The FastMCP tool decorator transforms ordinary Python functions into AI-callable endpoints, automatically generating schemas while preserving type hints and docstrings. The server name and tool name serve different purposes. The server identifies the process, while tools define callable operations. This single decorator bridges Python's static typing with dynamic AI model interactions.
The decorator that names the tool makes the tool nameless.